Hi everyone, thank you for joining my presentation. My name is Buddhi Patiguda from Master of Data Science. And under the supervision of Dr. Indubala, I have been working on a project focused on emotion analysis in mental health forums using natural language processing. In this presentation, I'll walk you through how I analyzed user-generated content from mental health platforms to detect emotional patterns and predict levels of psychological distress. Let's begin. Well, these are the areas I'm going to cover in this presentation. Let's quickly move to the first area, that is project motivation. Imagine you are going through a really difficult time. Maybe you are overwhelmed with stress, anxiety, or even feelings you can't fully explain. You don't feel ready to see a therapist or a doctor. And you may not have someone you feel comfortable opening up to. So, like many people, you and me turn to the internet, especially to online mental health forums, to express what you are going through and to seek support from others who might understand. Mental health forums have become safe spaces where thousands of people like you share their emotions every day. They aren't just conversations, they are emotional signals, sometimes subtle, sometimes urgent. Now, because of the large volume of posts, automated detection becomes extremely valuable. If a system can identify when someone is in severe distress early, it can help moderators prioritize responses, offer timely support, and potentially prevent harmful situations. However, many current models struggle because they don't fully understand the emotional depth behind what people write. They might miss the real level of distress hidden between the lines. And that's exactly where my project comes in, addressing this gap by building a more emotionally grounded severity detection approach. Next, I'll talk about the main objectives of this project. With that motivation in mind, I structured my project around three key objectives. Objective 1 was to build a severity classification model to categorize forum posts into mild, moderate, or severe crisis levels. This forms the foundation. Identify how serious a post is so that it can be prioritized appropriately. Once we had the severity predictions, Objective 2 focused on validating these labels emotionally. To do this, I use co-emotions probabilities along with the valence aerosol model to check whether the emotional intensity of post aligned with their assigned severity levels. Finally, Objective 3, which will be my future direction, involves designing a retrieval augmented generation or RAG-based support system. The idea here is to provide personalized guidance or supportive responses based on the predicted severity and emotional signals. Ideally, helping our users receive not just detection but also meaningful assistance. Okay, next we will see what kind of a data set I used and which platform I used to scrape that data. I used data from Beyond Blue. Beyond Blue is one of Australia's leading mental health platforms. It hosts anonymous discussions where people open up about conditions like depression, anxiety, and suicidal thoughts. If any of you are interested in this forum, you can visit www.beyondblue.org.au. Well, to build my dataset, I scrape posts from multiple Beyond Blue categories using Selenium and Beautiful Soup libraries. I collected post content, category labels, author IDs, and metadata such as timestamps and number of comments. To ensure ethical compliance, I only use publicly available posts and use post IDs, not their names. Let's take a closer look at the dataset behind this project. I scraped, you can see, over 14,000 posts from Beyond Blue categories like depression, anxiety, and suicidal thoughts. This is how scraped data looks like. Each post includes its title, content, and metadata like post date and category. Let's look at how the raw text data was cleaned and prepared for analysis. Once the raw data was collected, the first major step was preparing it for analysis. This began with data cleaning, where I removed invalid or noise entries such as empty post, broken HTML tags, links, and extremely short messages that provided no emotional context. This helps reduce confusion for the model. Next, I applied normalization. Here, I converted all text to lowercase, clean unnecessary punctuation, and standardized spacing. Finally, I moved into tokenization, which is a crucial step for deep learning models. In this process, each sentence is broken down into tokens that can be words or subwords, so that transformer-based architectures like BERT can interpret and learn from them effectively. Well, you may have noticed in many mental health posts, emotions are not only expressed through words, but also through emojis. Since emojis can strongly influence the emotional tone of a message, I didn't want to lose that signal during pre-processing. So, first I extracted all emojis and replaced them with descriptive text labels such as crying face or heartbreak. This allowed me to preserve their emotional meaning in a machine-readable form. Next, I use Google's Go Emotion model, which is a 28 emotion classifier trained specifically for social media style text. So this model helped me extract the top 5 dominant emotions for each post along with their full probability distribution. By doing this, I enrich each post with a detailed emotional profile, and that was later used to support severity validation and deeper analysis. Okay, here is a quick example of how the Go Emotion models actually works in practice. This post in left side, you can see it describes a person struggling with homelessness, anxiety about the future, and a sense of hopelessness. When it passed through the model, it assigns probabilities to 28 possible emotions. On the right hand, you can see the top 5 emotions with the highest confidence scores. In this case, the dominant emotion is nervousness, followed by sadness, fear, disappointment, and a small presence of caring. After pre-processing the text, the next step was to model the severity of the post. Before moving into emotion-driven modeling, I first needed a basic way to classify post severity. To begin with, I used a pre-trained mental BERT model, which automatically categorized posts into high-level mental health topics such as anxiety, depression, and self-harm. This helped detect the general context, but it didn't directly provide severity levels. So initially, I created rule-based logic to assign mild, moderate, or severe severity scores based on keyword intensity and emotional cues. This also helped to establish a starting dataset, but it wasn't deeply grounded in emotional meaning. I then tested some baseline models like logistic regression and random forest on this rule-based data. But these models only reached around 54% accuracy or 51-52% accuracy. And it made it clear that the early severity labels weren't strong enough and needed emotional validation. This is what led me to proceed toward rebuilding severity labels using emotional signals for better reliability. Since the baseline severity approach lacked emotional depth, I redefined severity using a more psychologically grounded method. To do this, I used probabilities from the Go emotion model and mapped each emotion into valence arousal space using values from Warnier lexicon. In this emotional plane, valence reflects how positive or negative an emotion is, and arousal reflects how psychologically activating or intense it is. For example, emotions like sadness and depression fall in negative valence and low arousal, while fear or panic fall in negative valence but high arousal. So based on this relationship, I reinterpreted severity levels in a more meaningful way. Mild distress usually reflects emotionally neutral or slightly negative feelings with low intensity. Moderate distress tends to be more negatively valenced with a higher level of emotional activation, such as worry or sadness. And severe crisis is characterized by high negative emotions combined with strong arousal, which is typical in panic or emotional breakdowns. This mapping confirmed me that the severity labels are not just categories but emotionally grounded. After mapping emotions to valence and arousal, I needed to verify whether the reinterpreted severity levels were emotionally coherent. So first I aggregated all posts within each severity group and calculated the average valence and arousal scores. This gave me a quantitative way to measure the emotional intensity and direction of each category. The results were as expected. Posts classified as mild distress showed relatively higher valence and lower arousal, which means they were more neutral or controlled emotionally. Moderate distress posts shifted towards more negative valence with moderate arousal, and severe crisis posts clearly showed strong negative valence combined with high emotional arousal, which aligns with urgent emotional states like panic or despair. After developing the initial model, the next step was to optimize it for better accuracy and stability. Once the severity labels were emotionally validated, I moved on to building a stronger classifier. For the model architecture, I selected dBERTA version 3 based by Microsoft. It is known for its strong contextual understanding and typically outperforms earlier models like BERT and Robota on test classification tasks. To improve robustness, I introduced several enhancements. I use focal loss to better handle class imbalance, especially since severe cases were fewer. I also used oversampling for underrepresented classes and applied early stopping to prevent overfitting. Finally, training was performed on Google Colab Pro using high-performance GPUs such as A100 and L4 that allowed me to efficient training of the model within a reasonable time frame. Okay, this slide shows how the model performance evolved over time. At first, I experimented with traditional machine learning models like logistic regression and random forest, which only achieved around 51-52% accuracy. These models struggle because I think they couldn't understand deeper emotional context. Using Mentalbot model gave a significant boost to about 78 accuracy, since it was specialized for mental health texts, but it still relied on my heuristic severity labels, which were emotionally inconsistent. After redefining severity using emotional grounding and applying transformer fine-tuning with dBERTA A version 3, performance further increased to 91.5%. Let's take a look what we discovered and what conclusions we can draw. Here I have summarized the emotional characteristics associated with each severity group based on the Go emotion probabilities. For mild pose, the most common emotions included curiosity, gratitude, and neutrality. These emotions suggest that users may be experiencing some concerns or reflections, but they are not in severe emotion struggle. Their emotion state is relatively balanced. In moderate post, we start to see emotions like sadness, disappointment, and confusion more frequently. So this reflects the This reflects the emotional strain. Users are distressed, but they may still be in the state where they are processing their struggles rather than experiencing crisis. Severe posts, on the other hand, were dominated by fear, nervousness, grief, and sometimes despair. These are high arousal, negatively valence emotions that suggest a high level of psychological pain and potentially indicate that the user might be reaching a critical emotional threshold requiring support or intervention. To ensure that severity grouping is scientifically grounded, I conducted a correlation analysis between the valence arousal values and the top emotional probabilities from GROW emotions. The person correlations results showed a clear alignment. Negative valence and high arousal emotions like fear and nervousness were highly associated with severe post. In contrast, moderate posts lean towards sadness and disappointment, which fall under moderate arousal and negative valence. Mild posts correlated more strongly with curiosity and gratitude, which represent low arousal and neutral or slightly positive valence. Next, I compared the original forum categories, anxiety, depression, and suicidal ideation, against the predicted severity levels to better understand how users' self-reported concerns align with actual emotional intensity. So you can see the heat map. Anxiety posts often high arousal and moderately low valence. This produces higher psychological activation. The circumplex model so naturally maps this to severe distress. Depression posts clustered mostly in the moderate category, and it suggests a sustained emotional burden but not always crisis intensity. These users may need support and intervention but are not necessarily in acute danger. Self-harm and suicidal ideation posts did align strongly with severe crisis, but interestingly, a noticeable portion appeared mild or moderate. When I examined such posts more closely in Beyond Blue website, many turned out to be self-reflective stories about past attempts or empathetic community discussions or awareness or coping related messages rather than immediate risks. So this indicates that not every post labeled self-harm represents an active crisis. Well, to summarize the current progress, the first two major objectives of this project have been successfully completed. I began by collecting and pre-processing posts from the Beyond Blue forum, and I achieved a high accuracy of over 91%. For my future work, which aligns with Objective 3, I aim to design a retrieval augmented generation or RAG framework for support guidance. That's all about my project and progression so far. Thank you all for listening. I look forward to any feedback. Feel free to reach out to me if you are curious about my project or want to collaborate on something similar.